In these examples, we'll be practicing step 1 and step 2 for chi-squared goodness of fit. Our first example is going to look at the question, is SIDS seasonal or not? That is sudden infant death syndrome something that occurs at higher or lower rates depending on the season? To look at this, we notice that in the very beginning here when we list that we have 4 categories. And I can tell I have 4 categories because deaths can either fit into summer, spring, fall, or winter. So the number of categories is 4. I use this to calculate degrees of freedom, which is just the number of categories minus 1, or 3 in this case. My next step is to go ahead and find my hypothesis. I always assume that my distribution fits and try and prove that it doesn't. Well, in this case here, I'm trying to prove that SIDS is seasonal. So HA will be SIDS is seasonal. That's what I'm looking for here. And so I need to think about what my null hypothesis is then. Well, if SIDS is seasonal, that means that some months are higher or lower than others, right? The opposite of that would be SIDS is equally likely for each season. So as if I'm trying to prove that seasonal, the opposite of that, what I need to assume is that it's not seasonal. That is, each season is equally likely. This is going to be important when we go to calculate chi-squared. Now let's look at another example. For this example, we're going to be looking at inheritance of physical traits within seeds. Our question is, does a certain plant follow a 9-3-3-1 inheritance? Now, this might take you back to Punnett squares when you were in middle or high school biology. And our question here is, once again, does it follow this or not? We've got data on plants with either wrinkled or smooth seeds, yellow or brown seeds. And so based on this, we're going to go ahead and start with our first thing, which is list. Now the number of categories we have here is really important. And that is, if I'm dealing with wrinkled or smooth, yellow or brown, that means seeds could be like wrinkled and yellow, maybe they're wrinkled and brown, maybe they're smooth and yellow, maybe they're smooth and brown. So it looks like I have 4 categories. I can also tell this because if I look up here, I have 9, 3, 3, 1. I got 4 categories listed there. That means my degrees of freedom is once again 3 because I take the number of categories minus 1. Second step is my hypothesis, my null and my alternative. Now I'm asking, does a certain plant follow a 9-3-3-1 inheritance? My null hypothesis is going to be like, well, okay, yeah, maybe it does. That is, the distribution fits. So we're going to say it follows a 9-3-3-1 inheritance. Once again, our null hypothesis is always the distribution fit. It says, yeah, it's 9-3-3-1 here. In the above example, it was, yeah, each season is equally likely. I'm trying to prove the opposite. That is